Here we have AP calculus AB problem. Okay, let's go to the question. Find the particular solution that satisfies the differential equation and the initial conditions. Okay, here we have the second derivative of the function f of x, that is f double prime of x equals to negative 2x positive 3. And we have the value of the first derivative of the function f of x at x equals to 2, that is f prime of 2 equals to 6. And also we have the value of the function at x equals to 1, that is f of 1 equals to 5. So particular solution means we have to find the function f of x. Okay, when I have the second derivative of the given function, there is a formula to get the first derivative of the function, that is integration the second derivative, that is f double prime of x dx. So when I integrate the second derivative with respect to x, that is equal to the first derivative of the function, that is f prime of x. Okay, now let me write f prime of x equals to integral. So we know the stuff that is equivalent to f double prime of x, that is negative 2x positive 3. We can plug in this negative 2x positive 3 for this f double prime of x. Then I'm getting negative 2x positive 3 times dx f prime of x equals to. Now we can integrate this. Here, when I look at the first term, negative 2 is a constant multiplied by the variable. When I do integration, if there is a constant multiplied by the variable, I have to keep the constant as it is, and I have to integrate the variable alone. So here, this x does not have any exponent, so I have to assume there is exponent 1. So we can integrate this x to the first part using the power rule of integration. That is, I have to add 1 to this exponent, and then I have to divide the result by the same exponent. When I add 1 to the exponent, then I'm getting x to the second part. It has to be divided by the same exponent, that is 2. Positive. Now I have to integrate the constant 3. Whenever I integrate a constant, I have to consider the variable with respect to which I am doing integration. Actually, this integration is being evaluated with respect to the variable x. So to get the integration of this constant 3, I have to multiply this constant 3 by the variable x. So 3x is the integration of the constant 3 with respect to x. Okay, now what I have to do is I have to add the constant of integration, that is c1. So here it's an indefinite integral. Whenever I evaluate indefinite integral, I must add the constant of integration. So here I am adding the constant of integration c1. Let me continue. F prime of x equals to, here we can simplify this one. That is this 2 and 2 can be cancelled. Then I'm getting negative x square, positive 3x, positive c1. Okay, now what I can do is I can use one of the initial conditions, that is f prime of 2 equals to 6, to evaluate the value of the constant of integration c1. So that is here I have to consider the value of x we have, that is 2. I have to plug in x equals to 2 into this result. Let me do it. That is f prime of 2 equals to, on the right side at everywhere I have to plug in x equals to 2. Then I'm getting negative 2 square positive 3 times 2 positive c1. We know the value of f prime of 2 that is given in the question itself, that is 6. So we can plug in 6 for this f prime of 2. Then I'm getting 6 equals to negative. So its value is the 2 square is the value of 2 square is 4, positive 3 times 2 is 6, positive c1. Then I'm getting 6 equals to, when I combine these two numbers, I'm getting 2 positive c1. Now let me add 2 from both sides. Then this 2 negative will cancel. I'm getting 4 equals to c1. Okay, now I got the value of the constant of integration in this f prime of x. So let me plug in the value over here. So f prime of x equals to negative x square, positive 3x. And for this c1, we can plug in 4 over here. Okay, now I got f prime of x, but my aim is to get f of x, the function f of x. So that is a particular solution for the given second order differential equation over here. Okay, there is a formula to get the function f of x when I know the first derivative f prime of x. Okay, to get the function f of x from the first derivative, that is from f prime of x, what I have to do is I have to integrate the first derivative, that is integral f prime of x dx. So then we get f of x equals to, for this f prime of x, I can plug in the stuff that is equivalent to f prime of x. So that is negative x square, positive 3x, positive 4 times dx. Okay, then we have f of x equals to, now we can integrate this one. Here negative, when I integrate this x square, I can use the power rule of integration. That is, I have to add 1 to the exponent and divide the result by the same exponent. When I add 1 to this exponent 2, it will be x to the third power. Now this result has to be divided by the same exponent, that is 3. Positive. Here 3 is a constant multiplied by the variable. When I do integration, I have to keep this constant as it is. The integration of this x using the power law of integration is x square over 2. Here we have a constant 4. When I integrate the constant 4 with respect to x, the 4 has to be multiplied by the variable x, that is 4x, positive c2. So again, it's an indefinite integral. So I'm adding the constant of integration c2 over here. Now I can use the other initial condition, that is f of 1 equals to 5, to evaluate the value of this constant of integration. So for that, what I have to do is I have to plug in x equals to 1 into the result over here. Okay, now let me do it. Then I'm getting f of 1 equals to negative 1 to the third power over 3, positive 3 times 1 square over 2, positive 4 times 1, positive C2. Okay, so the value of f of 1 is given in the question itself, that is 5. So we have 5 equals to, the evaluation of this one is negative 1/3, positive. So the evaluation of this one is 3 over 2, positive 4, positive C2. So 5 equals to, okay, now let's add these two fractions. So for that, what we have to do is we have to find the least common multiple of the two denominators, 3 and 2, that is 6. So what I can do is I can multiply the numerator and denominator of the first fraction by 2 to make the denominator as 6. So when I multiply both numerator and denominator by 2, I'm getting negative 2 over 6. Here I have to multiply both numerator and denominator by 3 to make the denominator as 6. Then I'm getting 9 over 6, positive 4, positive C2. Okay, now 5 equals to, now we can take the denominator in common because we have the common denominator for both the fractions. So we can take the denominator in common and we can add the numerators, negative 2, positive 9, positive 4, positive C2. Okay, now let me erase this stuff and continue the problem. Okay, let me continue over here. 5 equals to, when I combine negative 2, positive 9, I'm getting 7 over 6, positive 4, positive C2. 5 equals to, now to add the fraction and an integer, what I have to do is I have to multiply the integer over here by the denominator of the fraction. So once I'm done with this multiplication, I can take this 6 as a common denominator. 7 positive, 4 times 6 is 24 over 6, positive C2. Then I'm getting 5 equals to, when I add 24 and 7, I'm getting 31 over 6, positive C2. Okay, now to solve for C2, I have to get this 31 over 6. For that, I have to subtract 31 over 6 from both sides. Let me do it. So when I do so, this positive value, negative value will cancel. I'm getting 5 negative 31 over 6 equals to C2. Okay, now to do subtraction between an integer and a fraction, what I have to do is I have to multiply the integer by the denominator of the fraction. Once I'm done with this multiplication, I can take this 6 as a common denominator. Okay, let me continue over here. When I multiply this integer 5 by this denominator 6, I'm getting 30, negative 31. Now I can take the 6 as a common denominator. Okay, so the simplification of this one is negative 1 over 6. So that is the value of the constant of integration is negative 1 over 6. That I can plug in over here into the result of f of x to get the particular solution for the given second order differential equation. Okay, let me write the stuff over here. F of x equals to, we have negative x cube over 3. Then we have positive 3x square over 2, positive 4x. And for this C2, we can plug in negative 1 over 6. So this is a particular solution for the given second order differential equation.